Hi, I'm Justus Winn-Howard.
And I'm Zach Robinson.
And today we're going to be teaching you about related rates, and specifically the size of a cylinder in relation to the rate in which it grows. So here's our cylinder right here, and you'll see this is our radius, and this is our height. And this is the equation to find the volume of the cylinder, which is volume equals pi times the radius squared times height.
Alright, so we're going to pretend that the radius of this cylinder changes at a rate of 2 meters per second. So we have the change in radius, or the change in time, is 2 meters per second. And then we'll pretend that the height of this cylinder changes at 1 meter per second. So we have the change in height over the change in time, and we're setting that at 1 meter per second.
Alright, so now that we know these changes, we also need to know the change of the volume. And to do that, we need to use the product rule to derive this original equation. So to do that, we're first going to use the power rule to derive pi r squared. So dV over dt, which is the change in volume, is equal, using the power rule, you bring the 2 down in front, so which is 2 times pi, then you'd subtract 1 from the original exponent, so 2 minus 1 is 1, so it would just be 2 pi r times the change in radius over the change in time times height. And then the next step would be to add that to pi r squared times the derivative of height, and using the power rule that would end up just being 1, so it would be pi r squared times the change in height over the change in time. And that would be your original equation. And now we're going to combine these two together and take out like terms. The only likewise term that we have here is pi r, right? So we're going to take pi r, we're going to put it on the outside of the equation. And then what we have left is 2 times height, the change in radius over the change in time, plus the change in height over the change in time, plus times r. Alright, so that's where we are at this point.
So we have pi r, and then we're going to put in our values. We have 2 times the height, and we know the change in radius over the change in time is 2, plus the change in height over the change in time, which we set at 1, times r.
Alright, so for our final equation, we just need to simplify our equation up here. And so we'd still have pi r on the outside, but then inside the parentheses we have 2h times 2, which can simplify to 4h, and then we have plus 1 times r, which is just r. And this is the final equation to find the relative rate of this cylinder. And if you knew the values of r and h, you would simply plug that in, and that would be your relative rate. And that is how related rates work. I'm Justus Winn-Howard.
And I'm Zach Robinson.
And thanks for watching.